Thank you, Alison, for the introduction, and thanks everyone for sticking around for what is almost the end of the symposium. Once my slides come up, I'll get going, but look, I promise I'll make this fairly high level and not too technical. Just start by saying I've really been enjoying this session, hearing about the utility and application of IGS data and services and how they're providing impact to the global community. And I think that's one of the reasons why I enjoy being part of the Climate and Ocean Support Program in the Pacific, because the work we're doing is actually having a meaningful impact on the lives of those people who live, work and play across these amazing islands. Now, I'm not going to talk about the whole COSPPac program today. I'm just going to focus on a small part that Geoscience Australia is involved in. And I want to share with you some of the results from a report we published in April this year, which talks about the vertical motion of Pacific Island tide gauges between 2003 and 2022. And I'll just acknowledge the authors of that report there, Nicholas, Andrew, Salim, Simon, Anna and Gurun. And if there are any really technical questions, I might have to throw to Salim, who did a lot of the analysis work. So for those who haven't heard about the COSPPac program before, the aim is to support Pacific Island communities to use climate, ocean, sea level information to adapt and mitigate against the impacts of climate variability. And a key project under the program is the Pacific Sea Level and Geodetic Monitoring Project. And I think, as the saying goes, a picture tells 1,000 words. The picture there of the GNSS station in Tuvalu during a king tide, I think, answers the questions of why monitoring sea level is important in the Pacific. So Australia's been supporting the monitoring of sea levels in the Pacific for just over 30 years now. Last year we celebrated the 30th anniversary of the COSPPac program, or at least the incarnation of what it was 30 years ago. We started this work in response to concerns raised through the South Pacific Forum on the potential impacts of climate change and rising sea levels across the region. The project's funded by Australian aid, with some contribution now from the New Zealand government, and involves the Australian Bureau of Meteorology and Geoscience Australia, working with our regional partners, in particular the Pacific Community, or better known as SPC, and the national agencies. Through the project, sea level data has been continuously collected at tide gauges from each of the 13 participating countries. And since 2003, land motion data has also been collected as part of the project and is integrated into the sea level data to determine absolute sea levels or sea level change relative to the centre of the Earth. So the land motion data is collected or recorded across the Pacific Regional GNSS network, which is a network of 13 continuously operating reference stations located within a few kilometres of the tide gauges. Over the last year or so, or last couple of years now, we've been upgrading these stations, we've been modernising the receivers to be multi-GNSS, improving the power to ensure continuity of observation, and improving the telecommunications to enable more real-time observations. This is a station in Latoka, Fiji. It's pretty much typical of what all the 13 stations look like. We've got so we've got a concrete pillar anchored to the island, a choking antenna connected to two Septentrio Polar RX5 receivers in the cabinet there, along with power and telecommunication equipment. We've almost completed the upgrade of the network now. We have 2 stations left to go, PNG and Kiribati. We are a little bit behind where we wanted to be in that upgrade project, mainly due to the fact it started just as the pandemic kicked off and we had to pretty much sit back for 3 years where we couldn't access some of those islands. But I just want to acknowledge the amazing support we got from our national agencies and partners on those islands during that time to keep this important infrastructure running. And a big shout out to the team at the Tongan Ministry of Lands and Resources, and we saw a photo in the previous presentation of the Tongan station, but they actually managed to, via video chat, upgrade the entire equipment, which was really great to see some capacity being built in the region. So before I stop talking about the infrastructure, I just want to highlight some of the additional benefits that this infrastructure brings to the region and to the global community. So all of those 13 stations are now part of the IGS, and I think they form an integral part in the global geodesy supply chain, filling a gap in what is a large ocean. So with this project, it's great because we're utilising IGS products and services to analyse the data, but we're also contributing back through the stations. All of those stations now stream data in real time, and the data is being picked up by public works departments, environmental ministries, local surveyors to undertake RTK surveys, to support civil engineering and mapping applications and a variety of other things. The stations are also relied upon now for disaster risk reduction activities. These stations will form hopefully or form a key part of a proposal that's being investigated at the moment to enhance tsunami warning systems with GNSS in the Oceania region. And while on this slide, I'll just mention my good friend Vaipo from the Cook Islands. He's the chair of the Pacific Geospatial and Surveying Council, and one of the goals of the PGSC is to adopt a modern geodetic reference frame for the Pacific Islands, and these stations are helping achieve that goal. And I'm modelling the PGSC shirt today. So I've introduced the infrastructure, I guess now. At a fairly high level, I just want to walk through the process we taken to determine the vertical motion of the tide gauges. And I'm going to use the station at Apia and Samoa as an example. So for each of the stations, the GNSS data is transmitted to Geoscience Australia on a daily basis, where the data is analysed as part of our APREF workflow. I'm not going to go into that workflow in too much detail because Celine presented on that in session 2 of this conference. So looking at the vertical time series that comes out of that analysis, you can see for Apia, between 2003 and 2009, the GNSS station displayed very little vertical motion. In 2009, there was a magnitude 8.1 earthquake in Apia, which resulted in the station moving approximately 60 millimetres over the next 6 months, and then has continued to drop at a rate of about 8 millimetres a year. So that continuity in observation is really important because if you do the observation every year, you kind of miss some of that. But given the tide gauge is not located with the GNSS, that doesn't imply that the tide gauge is moving at the same motion. So to compare the motion of the GNSS with that of the tide gauge, we calculate a height difference every 18 months, and that's done by surveyors from our regional partner, SPC. So you can see a route there. I think, get this pointer. The GNSS station is located here, and there's a series of deep-driven benchmarks that follow the road along to the tide gauge of the wharf. So that levelling is undertaken using a total station differential levelling technique, following national guidelines that we have in Australia. So it's kind of what we used to call a zero water level, or now 2 root K in terms of accuracy. The height difference from the levelling is added to the GNSS height to compute the absolute height of the tide gauge with respect to the centre of the Earth. And in the case of Apia, as you can see down below here, the motion we're seeing is consistent with that of the GNSS station. So in this case, we can confidently say that the tide gauge in Apia since 2010 has been dropping at around 7.8 millimetres a year. So before jumping onto the results of the other islands, I just want to throw a few things to note. So the vertical motion that we talk about here only relates to the GNSS station and the tide gauge. We're not saying that the islands are going down or up in pole. They may be tilting, there may be localised movement. The only way we can be sure is to have additional infrastructure in the region. And that's something we're hoping that we can work on with some of our national agencies, regional partners, and hopefully some of you all in the room who operate infrastructure in the Pacific. The results do not include information regarding changes in sea level. It's purely land motion. But the Australian Bureau of Meteorology are taking the data from our report, and they'll integrate that with their tide gauge observations and provide an absolute sea level data set for the Pacific Island countries, which will improve their understanding of the impact of sea level change. So, the results. We've got 5 of the Pacific Island countries, so it's PNG, Samoa, Solomon Islands, Tonga and Tuvalu, the ones in yellow, orange and red. So they're going down. Tonga and Samoa are displaying the largest rates of motion, where they're dropping at 7.2 millimetres a year and 7.8 millimetres a year respectively. The tide gauges at Cook Islands, Federated States of Micronesia, Fiji, Kiribati, Nauru, Niue and the Republic of the Marshall Islands, so those in grey, have a rate of motion that's less than the uncertainty of the data. So either the rate of motion is close to zero, or we're going to need a much longer time series to distinguish that motion. And only one of the stations is experiencing a positive vertical rate of motion, which is Vanuatu, which is rising by 3.5 millimetres a year. Okay, final slide. I want to just change tack a little here and just talk about one of the aims of COSPPac is to build local capacity. So if a product or service being delivered by COSPPac can be undertaken or delivered by the country, then we really should support that. If it can't be done by the country, then we really want to support that being delivered through the region. So during the previous phase of COSPPac, Geoscience Australia successfully transitioned the responsibility of the differential levelling component to our regional partner SPC, so we no longer have to travel across the Pacific to do the levelling, and they've got a great team who are doing that now. During this phase of the program, we're transferring the responsibility for the establishment and maintenance of the GNSS stations to SPC, who are in turn working with the national agencies to train them in how to undertake sort of 6 monthly checks of the equipment. So we're starting to build capacity across the region, and I'm hoping that in the next 3 or so years that we are just managing the data and we're not having to actually go out to the region, which would be a great outcome. And in doing that, we're also encouraging our regional and national partners to consider participation in the IGS. So I think 2 years ago now, we've welcomed our first associate member from the Pacific region into the IGS, and I'm hoping as we transfer responsibility, build knowledge in the region, we can welcome more of our colleagues from the Pacific into this community. Thank you.